Are we missing anybody else? I think I've seen. Yep, I think everybody else. Okay, cool. So again, just to kind of talk through what we have left. We've got 4 school weeks left. We've got a review for the exams. We've got 2 sections to do. We've got a quiz and a test. Okay. We're gonna teach section. I'm gonna teach section 5.5, and then we're gonna quiz over just section 5.5. Okay. We're gonna just section 5.5, and then we're gonna quiz over it, and then I'm gonna teach you section 6.1, and then we're gonna have a 5.5 6.1 test. I know that seems really light to have just a test over just 2 sections. It's not as big of a test as normal ones are. This one's a 1-day test. So it should not be too bad. The difficult part is behind us. I don't know, the substitution rule, some people kind of get a little bit tripped up on the substitution rule. But we'll take it slow. We got a good amount of time for 2 sections. So I'll probably spend a couple days going through this, and then we'll quiz, a couple days going through section 6.1, and then we'll test, and then whatever remaining time we'll have to review for the exam. Does that sound good? Cool. All right. So, I was looking through my notes last period, and I was thinking through how to explain the substitution rule. But basically, the main thing behind it is like, if I were to ask you to integrate that, right? If I were to ask you to integrate that, you know what should happen, right? You know that the integral should be the antiderivative. But how do you find the antiderivative of something like this? Well, because there's a product and there's something inside a square root, it's got some composition look to it, right? Because there's something inside something else, and then there's something else happening around it, and we don't know how to deal with that right now, right? There's no way. I could not have put this on your past tests because we don't know how to find the antiderivative of that thing. Well, there's a way around it, but it only works in very specific cases, and it works. It's kind of like a weird process. It's kind of a little uncomfortable. It's called the substitution rule. Let me just show you what it is rather than walk you through an example first. Let me show you what it is, and then we'll do an example together. I had it in my notes to kind of like talk through an example, but I think it might be better to show you what it is and then do it with you. All right, so here's the substitution rule. We say that if u is equal to g of x, if u equals g of x is a differentiable function whose range is an interval I and f is a continuous on I. So basically, it exists within the interval you're looking for, or it exists everywhere. Right? It's always continuous, and the range is within the interval. And it's got this like chain rule-ish look to it. It's got this chain rule-y thing. You guys done? Is everybody coming back?
Yeah.
Sweet. Let's go. I'm so glad I decided to teach a bit. I'll pause for a minute then. We'll let everybody come back in. What's that? We'll see. Did you just start? I just started. It was perfect timing. Come on in. The water's warm. I figured people would be skipping into this class. Ready to go. Monday morning. I didn't take it. If I took offense to how people felt about math, yeah, we could put it on. Many years ago. We screwed up the NHS connection. All right. We have everybody there? Cool, perfect. So I just got done talking about, just to kind of backtrack just 30 seconds. This is going to be basically how to find how to find integrals of things like this. Right? Take a look up on the screen there that this function where we have, almost like a composition look to it, right? I've got a square root of another function and then something going on the outside. Like, how do we integrate that? We don't know right now. But there is a technique that you can do to work your way around it. Let me show you. It's called the substitution rule. Okay, so basically it says that if you have the integral of f of g of x times g prime of x dx. Now that's a really, really unique setup. It's a very unique setup, a very particular setup. But it'll happen a lot. And I'll make it happen a lot. If you have the integral of f of g of x, where you've got something inside something else, a g of x inside f of x, multiplied by g prime of x. So again, it's got that chain rule look to it, where you've got a derivative multiplied to another function, another composite function. It's actually equivalent to, and thank you, Mr. James Stewart, for writing the book like this. Thank you for giving us this notation. It's also the integral of fu du. Really? Call it fa. Okay. Now, what is u again? U is g of x, right? We define u to be g of x. So what we're going to be doing is we're introducing a new variable. We're calling it u. The AP Calc class learned this as u substitution. U substitution. We just call it the substitution rule. We introduce a new variable, and we say, okay, this variable represents an entire function. We're going to call that variable u, and we're going to say that it's equivalent to g of x, some nested function within f. And then we can say if u is equal to g of x, and we've got this setup where we've got a composite function with g of x inside of it, multiplied by the derivative of g, then we can replace this whole chunk with just f of u. Okay. And notice what else changes. Dx, du. Okay. Honestly, that really is just notation. It's actually in bold down here. It is permissible to operate with dx and du after integral signs as if they were differentials. And that's really what we'll do here at the beginning. Okay, so let's work through an example. How does this apply? How does this work? Now, think about if I were to try to give you this integral on the test last week, which, by the way, your class is graded. They're not in the grade book yet. I am finishing up the very last page of 6th periods, or 7th periods, excuse me. I should be putting them in the grade book next period. Hopefully, if nobody sidetracks me. Find the integral of x to the third cosine x to the fourth plus 2 dx. Again, there's no way I could have possibly done this on the test last week. Can you recognize a function within another function? What's inside cosine? X to the fourth plus 2, right? So let's make u x to the fourth plus 2. And I don't know why. I use a cursive u. Call it mu for my statistics people. That is just the variable that I'm going to be using. U is equivalent to x to the fourth plus 2. Okay, once you define what you're going to substitute in, once you define u, there's your g of x. What I'm going to do is calculate the derivative of it. Okay, now I'm calculating the derivative with respect to x, correct? So I'm going to say du is equivalent to 4x to the third dx. 4x to the third dx. Now, what you have to look for are pieces of that derivative within the original function. Now, we were dealing with this cosine x to the fourth plus 2. What's on the outside of the cosine? What else is there on the outside of the cosine? X to the third dx, right? We see on the outside of the cosine is x to the third dx. Do you see x to the third dx inside our derivative? But there's this pesky 4, right? I don't want that 4 to be there. So if you don't want it to be there, let's move it over to the other side. So let's say 1/4 du is equal to x to the third dx. Okay, now watch what we can do. This is really equivalent, kind of like two separate parts to this problem. This is really equivalent to cosine x to the fourth plus 2 times x to the third dx, right? All I did was just move it around. So I'm going to take this and substitute in 1/4 du, as well as this is going to go in for u. Excuse me, a u is going to go in for that, excuse me. So this is going to be cosine. We defined x to the fourth plus 2 to be u. And we know x to the third dx is 1/4 du. You follow me there? Now, what did that do? Well, can you find the antiderivative now? Can you find the integral now? Yeah. It's no longer some weird complex function. Now, I honestly just have 1/4 cosine u du. Oops, I forgot my pen. U du. Okay, so what is the integral of cosine? Sine, right? The integral of cosine is sine. So this is 1/4 sine. The 1/4 stays, right? It's not plus 1/4, it's 1/4 times. So 1/4 sine u plus c. The only thing that I have left to do is go back in. Now, was the original problem, did the original problem have any u's in it? No, it only had x's in it, right? So I have to go back in and take out u, and in its place, substitute back in x to the fourth plus 2. So 1/4 sine of x to the fourth plus 2 plus c. That is actually the integral of our very beginning piece there. Can I move it up just a little bit? Ooh, that's too much. Yeah, there we go. That whole integral evaluates to be 1/4 sine x to the fourth plus 2 plus c. Kind of cool, right? But it was a very specific case. Like, if there had not been this x to the third outside, I'm out of luck, right? If there had not been, well, that x to the third needed to be there. If that had even been an x squared, I'm out of luck. Got to do something else, okay? Let's take a look at our next one here. Because the whole idea is to calculate a really difficult integral just by substituting in something easier, like just a variable, just a u. This is a relatively simple example here. Okay, what do you think the u is going to be? Look for a function that's nested inside something else. What do you think u is going to be in this case? 2x plus 1. Right? You create a variable to substitute into the function to make it a little less complicated. Okay. Because right now, like here's where I'm at. right? I know that's going to have to change to a du. I got to figure out what is equivalent to dx. Okay, let's differentiate. Du is equal to 2 dx, right? The derivative of 2x plus 1 is just 2, so it's 2 dx. Now, do you see a 2 dx outside of the square root? Outside of the square root? No, I just see a dx, right? The only other additional thing outside of the square root is just a dx. So get the 2 away. Divide it over to the other side. 1/2 du is equivalent to dx. See, there's nothing else on the outside. There's no like x to the third sitting out there. It's literally just the dx. That's the only thing left out there. So that means in place of dx, I can write times 1/2 du. I don't know what it is about it. I like to put the whole number or the constant in front. 1/2 u du. Could I have done that on our test at the end of last week? Oh yeah, that's a relatively easy one, right? Okay, let's evaluate the antiderivative. U again, square root of u is u to the 1/2, right? So this is 1/2 u to the 3/2 over 3/2 plus c. Okay, let's reduce that down a little bit because that looks a little weird. So 1/2 divided by 3/2 is 1/2 times 2/3. Cancel. 1/3, right? So that is 1/3 u to the 3/2 plus c. And the only thing left to do is take out the variable we introduced and replace it back with what we put in for. 1/3 2x plus 1 to the 3/2 plus c. I mean, it looks really similar to what we might predict the integral might be. Like if you had not known the substitution rule and you look at the very beginning and you're like, I wonder what the integral is going to be. I bet it's got something with fractions because that square root is a 1/2 power. And you're probably going to have to bump it up. It's probably a 3/2 power in the end. Look, a 3/2 power in the end. But I'm probably going to do something with this 2x plus 1. And I mean, that's the weird part. That's the substitution part about this. That's where that 1/3 comes from on the outside. Let's try another one. You know, some of these problems, I'm thinking back to, I'm just now, the light bulb's going off in my head. I'm thinking back to like trig identities. You know how sometimes like in trig identities, there was that technique where you like work the left side and then maybe work the right side backward to try to figure out what path to lead on? I think about this problem in the same way. Let's first start off by saying, what's our u going to be in this case? 1 minus 4x squared, right? I think it's pretty easy to see. What did I do? 1 over. 1 minus 4x squared is going to be my u. For example, like I know that I already have this x over square root of u dx. I need all the x's to get out of there, right? The substitution rule needs all the x's to go away. So maybe I should like simplify this down a little bit so that I can figure what needs to go away. What am I looking for in my derivative? Here's what I mean. Okay, let's pull the x out of the numerator. Right? And maybe let's pull the part with the u into the front of the integral. And you know what? Why not? Because I'm going to have to in the end. Let's put that u as a -1 power. Get it out of the denominator. Square root of u to the negative first. And let's put the x over there with dx. So what am I looking for when I find the derivative here? I'm looking for an x dx. You follow me? I worked the end a little bit backwards so that I knew what I was looking for in my derivative. So let's find the derivative. Du is going to be, the 1 goes away, -8 x dx. You see the x dx? You see what you're looking for? Okay, get the -8 out of the way. Let's divide it over to the other side. -1/8 du is equal to x dx. And now I can plug in -1/8 du. So that is equivalent to the integral of, let's call that -1/2. U to the -1/2, -1/8 du. Now let's find the antiderivative. Okay, let's find the antiderivative now. So that's going to be equivalent to, okay, bump it up 1, u to the +1/2 over 1/2. I got to bring this -1/8 out front, right? That's not a -1/8. That's like a -1/8. That's the times, right? So that's why you can bring it out front, multiply it to it, plus c. Let's reduce that. -1/8 divided by 1/2 is multiplied by 2. So cross simplify, there's a 1 and a 4. So -1/4. So that's equivalent to -1/4 u to the 1/2 plus c. Okay, let's make it a square root. -1/4 square root of u plus c. And in the end, once I am fully simplified down, you go back in, replace u with what you started taking out, 1 minus 4x squared. Plus c. Sound good? What's our next one? Ooh, our next one's super easy. Super easy. And then we'll stop there. Why is this one going to be super easy? What's it got in it? It's got an E. Oh, we like E. E stands for easy. I just thought of that. Now, what is U going to be? What is U going to be? 5x. Yeah. Actually, our U doesn't have E in it. It's just 5x. But that's a pretty easy derivative too, right? du is equivalent to 5 dx. Okay, so that means I can take the integral of e to the u. Now, look here. Is there anything outside with dx or outside of e to the 5x? No, it's just dx. Okay, get the 5 away. 1/5 du is dx. So that means this is going to be times 1/5 du. And again, I like that number out front. 1/5 e to the u du. And again, e to the something is a super easy antiderivative as well, right? E to the something is e to the something. So this is really just 1/5 e to the u. I don't know why I wrote that like that. E to the u plus c. And last thing we do is plug that 5x back in. 1/5 e to the 5x plus c. Cool. Sound good? All right. We'll stop there for today. Give you a nice, easy Monday.